Alrighty, so we've learned to solve systems. Now we have learned to solve systems with word problems. Today students will be able to write and solve systems in mathematical and real world problems. So we're going to be able to write them. Okay, so systems of equations, like we've gone over, is just two equations. Graphing, you can solve it by graphing, seeing where they cross. You can solve it by substitution, substituting things. You can solve it by eliminations, eliminating things. A solution is where they cross, or the x and y that makes these two statements true. Intersection, that's where they cross. One solution means they only cross once. Infinite solutions mean they cross infinite amount of times. No solutions means they never ever cross at all, and these lines are what? Parallel. Independent system has only one solution. Dependent system can have more than one solution. Consistent system has at least one solution. Inconsistent system has no solution. Here we go. So we're going to look at a few of these together, and then you're going to do the rest on your own. So let's look at number 1. Number 1 says, which graph best represents a solution to this system of equations? Okay, to this system of equations. So here's how I would do this. Let's move them into y equals. Since we have pictures of graphs, let's go ahead and move them into y equals. So move the x divided by y, right? Can you use matrix on this? Sure, but we're not going to. Well, I mean, you can, but I'm not going to. So this is negative 3y equals that positive 2 moved over becomes a negative x plus 0, but you don't have to write that. Okay? Then divide by this negative 3. Move the x divided by y. Y equals negative 2 divided by negative 3 is just positive 2 over 3. So this is our first equation. Now we're going to do our second equation. Move the x. So we have 2y equals, this positive x moved over becomes a negative x minus 7. So we've moved our x. Now we need to divide by y. So we have y equals, what's this negative 1 divided by 2? It's negative 1 over 2. Negative 7 over 2 is negative 7 over 2. Okay, so now let's type them into our calculators. You ready? Go to y equals. Type in your first equation. Y equals 2/3 x. Parentheses, 2/3 x. Okay, now let's type in this side. Negative 1 over 2 x minus, parentheses, 7 over 2. Be sure to use parentheses. It's super important. Now graph. So we want to find the graph that looks like this one, but we can even take this a step farther. You ready? Hit second, trace, 5, intersect. Okay? We've used this before. Enter, enter, enter. This will tell you the intersection is at negative 3, negative 2. Okay? So if the intersection is at negative 3, negative 2, let's find that. 1, 2, 3, 1, 2. Does it cross here? Nope. 1, 2, 3, 1, 2. Nope. 1, 2, 3, 1, 2. Nope. 1, 2, 3, 1, 2. Yes. And it looks just like the graph we had. Okay? So that's the way to do it. Now, you could have also solved this with matrix, found the solution, and done the same thing. Just plot the point and see where they cross. Okay? Now let's look at number 4. Number 4. The system of linear equations 2x plus y equals 1 and y equals negative 1/2 x plus 1 are graphed on the same coordinate grid. Which of the following is the solution to the system of linear equations? So these, again, I would suggest graphing it. Okay. Move the x over. So this becomes y equals, that 2 coming over here makes it a negative 2x plus 1. And then we have this one. Y equals negative 1/2 x plus 1. Now you can graph it here, or you can graph in your calculator. So the first one was y equals negative 2 x plus 1. Okay, and the next one was parentheses negative 1/2 x plus 1. Graph. Okay, so let's see where they cross. Second, trace, 5, enter, enter, enter. They cross at 0, 1. So at 0, 1. Which answer choice is that? Not that one, not that one, not that one. It's not here. Okay. Alrighty, on the next page, let's look at... Actually, we're not going to do any of these because I feel like you can handle all of these on your own. I'm fully confident. Next page. So I know I want to do number 10 with you guys. Some values for two linear equations are shown in the tables below. Okay. What is the solution to the system of equations represented by these graphs? Or by these tables? I'm going to use stat. So go to stat, edit, type in this table. We have 2, negative 4, 5, negative 1, 5, negative 7, 11, negative 1. Stat, over to calc. This is linear, so it's 4. Y equals 2x plus 1. So this is y equals 2x plus 1. Let's do the next one. So edit. Let's clear these. Here we go. So we have 5, negative 3, 0, 1. And over here we have 11, negative 13, negative 4, negative 1. Stat, over to calc, 4. Y equals 3x minus 4. Okay, so now let's type those in. So we have, and we have y equals 3x minus 4. Whoops. 3x minus 4. And then the next one is y equals 2x plus 1. Graph. All right, second, trace 5. Enter, enter, enter. It intersects at 5, 11. So the answer will be 5, 11. Now, here's also a little tip. Remember, it's the point where they intersect, so they should both have that point. Okay, that's another little tip for you. Okay, number 11. Number 11, which of the following is the solution to this system of linear equations? So here's how we're going to do this. I'm going to use, you can use any way you want. I'm going to show you another way. So this is the x and this is the y. So what we're going to do is plug this in for x and this for y and see if this statement right here is true. So 17 over 3 stow alpha x. We just told our calculator that x is 17 over 3. Now 4 stow alpha y. We just told our calculator that y is 4. So let's type this in. 3 alpha x minus alpha y. Enter. Oops. 3 alpha x minus alpha y. Is that 13? Oh, it's supposed to be negative 13, so that's not correct. We're going to do it again with these. So negative 1 stow alpha x and 8 over 3 stow alpha y. We're going to do it again. 3 alpha x minus alpha y. Is that negative 13? Nope. Let's try the next one. Negative 3 stow alpha x, 4 stow alpha y. So it's 3 alpha x minus alpha y. Is that negative 13? Yes, but we still want to check that last one because it is possible that this might still work. So negative 3 stow alpha x, enter, negative 4 stow alpha y. So now we have 3 alpha x minus alpha y. Is that negative 13? No. So your answer here is H. So that's another method you could use for this. Okay, number 12. Number 12. The equation of two lines are that and that. What is the value of x in the solution for the system of equations? Okay, so this one's already in y equals, so I'm just going to go ahead and make this y equals 2. Move the x, so we have negative y equals negative 6x 4, then divide by that negative. Cancels out here, y equals 6x minus 4. Okay, and we're going to type that into our calculators. So y equals, let's type in the one we already had, 4x plus 2. And then let's type in the second one, 6x minus 4. Graph. Now, second, trace, 5, enter, enter, enter. Whoop, it went away. I think I'm doing it too fast. Second trace, 5, enter, enter, enter. So the intersection's at 314. What's it asking for? It wants the x in the solution. X, y. So it's 3. Okay. All right, so now I want to go over some problems that I think you might need a little bit of help on. So first, number 13. The graph of the system of linear equations is shown below. Which of the following is a solution to the system of linear equations? You can use stat by typing in these points, finding their equations, and typing that into y equals. Or just do the slope, down 1 over 5, and keep going, down 1 over 5. And do the same here until you see where they cross, okay? Number 14 says, which is the solution to this pair of linear equations? Okay, so I want to point something out to you here. It has to be x, y equals number, right? This y is in the wrong spot. You'll need to switch these two. Be sure their signs stay the same because you're not changing it over the equal sign. You're just trading places. So it should be negative 2x plus 5. Okay, negative 2x plus 5. Y plus 5y. Now I want to go back because there was a problem back here that I wanted to go over with you guys as well. That's right, number 9. The sum of the perimeters of two different squares is 32 centimeters, and the difference between the perimeters is 8 centimeters. If x represents the side length of the larger square and y represents the side length of the smaller square, which of the following systems of equations could be used to find the dimensions of the squares? So they tell us the perimeters. What's the perimeter? It's adding up all the sides. So I want you to keep in mind here that this is x and this is y. Okay, keep that in mind when doing it. X is not the perimeter. X is just the side length. Okay, so when you're doing this, I want you to keep that in mind. All right, let me know if you need any help. You should be able to finish the rest of this worksheet. Submit your answers online. Do not turn it in without a 100. And don't just guess the answers because, let's be honest, that doesn't help you on the test. So you really need to do well on this worksheet and understand what's going on it, okay? Let me know if you have any questions. Good luck.